All right, the recording has started. The next thing that we want to say is, please let's try to mute our microphones. Okay, there will be opportunities for us to get feedback from you. There are opportunities for you to ask questions, but please let's be kind to one another by ensuring that we mute our, computers or phones as we join. Let me share my screen. If you can see my screen, please let me know. Can you see my, can you see my screen? Hello, can somebody help me? Can you see my screen?
You see your screen.
Can't see my screen.
No,
No, you can. You should see my screen. What about now?
yes.
Fantastic. So, good evening, everyone. My name is Peter Okwe, and I'm presenting this on behalf of Professor Olubusoye. This is a 10 weeks lecture on fundamentals of data science using R programming. Okay, so it's possible to learn data science using other tools like Python, Java. These are programming languages. But we have adopted R because it is the closest programming language to statistics. This language R used to be called S. Okay, so again, we'll be hopping from accepting people into the class and delivering the materials. Try not to be distracted. It can be very difficult, okay? So last week, we defined data science. We said it's an interdisciplinary field that combines statistical methods, programming, and the domain experts. The goal is that with data science, you're able to extract insights and knowledge from data, whether structured or unstructured. I'm not going to revisit everything, but I will touch on the key things. So data science involves collection of data, pre-processing the data, and then interpreting it. The goal is for decision making. So we looked at the importance of data science. Okay, and we saw that it has a wide range of application. For instance, it is useful in health and medicine, and it is data science that powers artificial intelligence. We went on last week to begin to, and I think last week when I was delivering this material, I wasn't really sharing my screen. I watched the videos later. And that's why this session is very important. So we saw that data science can be applied in many fields, okay, which is important. In fact, in my view, there's hardly any field where data science cannot be applied. And then we mentioned some of those key fields like business and finance, marketing and e-commerce. And we really spent time talking about some of these things. Interestingly, we talked about the fact that you can apply data science in government and policy making. By the way, can you help me? Can you see my screen? Because that becomes very important in today's session. I must be sure that you are seeing my screen so that at the end of the day, we won't waste time, not sharing my screen. Can you still see my screen?
Yes.
Oh, fantastic. Fantastic. Okay. People will keep joining until when enough people have joined and they'll be stable and they will keep moving. Don't worry, we'll get used to this idea of just hopping left and right, because later we'll start focusing on programming the real hands-on. And when it's time for hands-on, none of us really care about whether people are joining or we are being distracted. So data science is useful in science and engineering, obviously. So we went on to talk about different careers that you can explore. And we are glad that there are students in our midst. We believe that they are the ones that really need to know these different fields. We talked about them. And then we also said that even for those of us that are aged, it's possible for us to change career. And in the field of data science, age is not a factor. Okay, so don't think you are too old to learn data science. No, no, no. It's about problem solving. And there are always problems to solve in this world. So what are the key skills that are needed? The skills are divided into two. There are technical skills that we need to acquire, and there are soft skills. The technical skills include knowing at least one programming language. If you know more than one, better. Okay. So we have decided that for this particular set, or for this first interaction with us, we are going to focus on our programming language. We can also explore other ones later. Then we need to know grade 12, at least senior secondary school statistics and probability, and it's up to the SS2, SS3 level. That should be sufficient. Then I have an idea of how to interpret graphs and figures. That comes with experience. And then if we have ever heard about machine learning and AI, that could be a plus. But those are the skills that you are going to acquire, even if you don't have them before now, which means that along this journey, you are going to be more proficient with our programming. Your statistics and probability will be tested. And if you have deficiencies, they will improve. Then we'll learn some of these tools. Of course, for us, we are going to focus on ggplot2, which is a library in R. We'll talk about libraries later, but that's like a tool that we'll learn in R. Finally, once you delve into the field of data science, you have to talk about machine learning and AI. More of that in the coming weeks, but today sets the tone. What about the soft skills? These are skills that we already have acquired. Since many of us are lecturers or admin staff, we already have acquired these skills, but we'll put them to test. Discovering problems, providing solutions to problems, thinking critically. The goal of critical thinking is problem solving, improving our ability to communicate what we have, as solutions to our clients or stakeholders, telling it in a beautiful way so that it will be a story that will make sense to the listener. Then all of us have expertise in different areas. When we do data science, we are supposed to bring in our expertise to make that solution really, speak to the problem that is at hand. Some of these things I'm saying, I will say them over and over again as we proceed. So what is the future of data science? Those are the things you see there. There's a high demand for it, okay? And there are other issues regarding ethical challenges, okay? So we don't have to talk about all of these things, but we'll keep touching on them as we progress. So what then is the data science workflow? We say that it's a systematic process used to transform raw data into meaningful insights. It's important to recognize that the data that you get for the purpose of applying data science is usually very messy, very dirty, very ugly, very irritating, because it's like going to a refuse dump, trying to pick out. It's like even mining lithium or oil or whatever. If you see the raw form of gold, you will not really appreciate it. But if you're able to refine it and transform and make something beautiful out of it, then you have something precious. That idea is what I want you to have when it comes to the workflow of data science. How do you take something raw to become something useful? Okay, then again, the goal is to ensure efficiency, accuracy, and reproducibility. So without repeating some of these things on the screen, it's important for us to emphasize these steps. By far, the most important aspect of last week's lecture, to understand these steps. That is the data science process, the end-to-end work that is done in data science. So if you say you are a data scientist or you are applying data science to solving a problem, these are at a high level, the processes that you need to take. The first process is to know that you must understand the problem. Failure to properly define the problem is a recipe for a solution that looks good but does not address the problem. So a data scientist is somebody who is able to use data to address problems. And if you don't define that problem well, you could have a solution, which I'm saying again, might not address the problem. So that's a very fundamental step. We must understand the problem. Take, for instance, trying to determine the best price for PMS. Okay, that's well. How do we solve that problem? If we don't understand the dynamics of that whole sector, we might provide a solution that on paper looks good, but we apply it to the situation and it doesn't address it. So being able to understand, the constraints and the issues around a particular problem is a very good starting point. The next thing is building on top of that. If you've been able to define that problem very well, then you need to harvest data. Okay, so how do we get data? There are many ways, and some of them are mentioned here. You can go to a database and get data, like, go to maybe FSS, Federal School of Statistics. You can get data from people. Okay, you can go to NBS, Nigerian Bureau of Statistics. You can get data from even online sources that are not even in our domain. Okay, so it's important for us to recognize that the next thing after you have understood the problem is to get data. Okay, and you need to get data that will address the problem, and that's difficult, especially in our country. Difficult to believe that the data you have is going to address your problem. You need a lot of help. Okay, sometimes people say connection. So when you get your data, you need now to take care of that data, because in its form, it's not going to be properly structured. However, of course, in this whole, during these next 10 weeks, we are going to be dealing with structured and unstructured data. For instance, if you are recording, like we are recording this class now, we are recording the video, but again, there's audio on top of it. There are images, okay? So those are 3 different types of files: audio, video, and images. Those files are not usually structured, especially when we are even talking about this audio. There are certain things that I'm saying now that are not so useful. They are also, although can be converted into text, but they are not really adding meaning. What are we trying to say? We need to learn how to remove those irrelevant, data, which we call noise in statistics. Okay, we need to know how to deal with duplicate data. We need to know how to deal with missing data, because at the end of the day, even when you have like a spreadsheet, sometimes some values are missing, sometimes they are repeated, some values are extreme. So there's need for us to acquire that skill in this class using our programming language on how to transform data, which you call pre-processing. That is, before you apply your statistical method or your machine learning method, to process it. Okay, so applying your machine learning method is actually a processing technique. Please give me a moment. I'm sorry, just a moment. Okay, sorry about that. I had a call, and I felt that call could be one of us who wants to join the class. Okay, otherwise I wouldn't have even bothered picking up that call. Am I back? Can you hear me, please?
Yes, we can hear you.
Okay, sorry to interrupt. Are we making progress? Are we saying things that are adding values so that we will know?
Yes, yes, yes.
Okay, thank you very much. Thank you for the kind words that you have given. Someone wants to join the meeting. So what are we saying? We are saying that at the end of the day, you need to clean your data. And because you are still going to process the data when you are doing your machine learning and statistical learning, the fact that you are processing the data at this stage is why we call it pre-processing. Okay, a kind of processing before the real processing. The real processing is trying to make meaning out of data, but this level of processing is trying to convert the data into a form that will be useful for further analysis. I hope that makes sense. Then after that, you now go to what everybody likes. If you see the way Prof has structured this note, here it says steps in data science processes. He has given us step 1, problem definition and understanding. Step 2, data collection. Step 3, data cleaning and pre-processing. And then we now see steps in data science processes. Continued. These next steps, they are the steps that most people want to look out for. When somebody says, I want to learn data science, it's actually these steps that the person is really talking about. And truly, these steps are the core in data science. However, they depend on the first 3 steps. If you don't deal with those first 3 steps properly, this is not going to give you a result that is useful. I think, in my view, this is why many problems have not been solved. Even though data science, machine learning, AI are really doing a lot, there are still a lot of problems that have not been tackled correctly because the first 3 steps were not taken care of. First, people who do data science don't even have an understanding of the problems, because most people who do data science don't have expertise in those areas, or sometimes they ignore certain regions of the world. In fact, the kind of solutions that they provide are tailored for certain developed parts of the globe. So we need to be in that field so that we can provide additional training data. Okay, you and I can also, let me try to admit everybody. Admit, brilliant. I don't want to, yeah, great. So having said that, what we are saying is, if your data, if you don't understand the problem, you don't have data that is, reliable and valid, and you don't pre-process your data properly, at the end of the day, when you start to do analysis, building your model and evaluation, you are going to get results though, but they might not be very great results. So we have data analysis, building and evaluating our models, and then interpreting the models. So last week we said, and we are saying again, we need to understand that when data is collected, there are different types. And some of the types are what you see on the screen. Okay, structured, unstructured. You can get data by scraping the internet, and sometimes real-time data. What then are the challenges with collecting data? First, the issue of security and privacy. Data comes in different formats, and some of these formats are inconsistent and incompatible. Okay, you can have data in starter form, it can be in Excel sheets, it can be in JSON form. There's too numerous formats, and you need plenty of skill to be able to marry those formats and then bring out results that are very efficient. So remember that we said there are 6 steps, 6 stages. Should be able to talk about this, without consulting any material. When one, understanding the problem statement, okay, defining it and understanding the objectives and all that. Secondly, you look for data, you collect data, and then you pre-process the data. And when you have done that, you start doing exploration. You explore and you check for details that you can quickly get from the data and do preliminary analysis. And then you build your model where you do training and testing. And finally, you evaluate the model for the purpose of decision making. So that's just like the pipeline. So let's assume that we understand our problems, because problems are usually very specific, okay? Problem A will not be the same as problem B. And even if they are the same, they might occur at different times and in different contexts. So we cannot just conclude that this is the way you have to solve a particular problem. We need to understand the demands of that problem and then know what will be the best solution to that. That's why we have so many models, so many methods, so many solutions tailored towards specific problems. Once you have captured data, the next thing is to clean the data, remove all the things that are going to cause your data not to give you the desired results. So here we have data cleaning, also maybe sometimes referred to as pre-processing. What do we do there? We handle missing data, we remove duplicates and inconsistency, we standardize our data, and we do what we call feature engineering. What does that mean? Sometimes we have too many variables and some of them not contributing that much. So we do a lot of stuff that we're going to explain later to be able to either combine features or remove features that are not contributing. A lot of things that we do there, which we are going to see as we continue. And that's part of what we are looking at in lesson 2. Okay, so with data analysis and interpretation, there's exploratory data analysis, which is just what you do in statistics, getting summaries of the data. We're going to do it today, mean, median, mode, variance, and all that stuff. And then we can even move to inferential analysis. I know there are statisticians here where we do hypothesis testing and confidence interval. And without overstating it, we need to make sure that we translate statistics into meaningful narratives. That's what we call storytelling. So in the end, if you're able to communicate your solution to your audience, then it means that you've done something that when they now use, they give you feedback so that you know whether to refine your solution, to improve on it, or to abandon it altogether. So that feedback loop is important. So if I was going to add anything to the data science workflow, by the end of the application, I'll go back and say feedback, and then we'll go back. Maybe you need to collect more data, maybe change the format, then maybe do some more analysis, maybe use another model, and then you evaluate the model, and then your client sees it, say, I don't like this feature. It gives you feedback, you go back. Maybe you don't need to collect data again. Maybe you don't need to pre-process data. Maybe you need to use other efficient models and all of that. So what tools are used in data science? Many tools. We are going to use R, and we are going to do a lot of using R today, hopefully. Okay, so we say R is best for statistical computing and data visualization. The others have their own advantages. You have access to these materials, so we don't need to speak to them again. So introduction to R programming. These are notes that we read last week, and we are not planning to read them today again. But let me just say something about extensive libraries. That's what sets R apart. There are so many solutions that some scientists have provided. They call them libraries. So you don't have to reinvent the wheels. You only need to get those libraries, put them in the instance of your work, just like getting a tool to fix your car. They already made the tools. You don't have to go and manufacture the tool again. And then some of the common ones are ggplot2 for visualization. There's dplyr for data manipulation. There's Caret for machine learning, and there's Steadyverse for data science. We are going to use each of these ones, okay? So just remain focused, knowing that we are not just telling you what we hopefully, we are telling you things that we eventually do. So like I said, it's easier to get distracted when people are joining the class, but I'll try my best to keep you focused. Okay, good. So application of R in data science. So you can see there, statistical analysis, visualization, machine learning, data wrangling and cleaning. That's today's tutorial. And we are going to do a real hands-on exercise. Okay, so there are other areas where you can apply data science, business and finance, bioinformatics and healthcare, government and policy making. So why use R? We said R is open source. You don't need to pay for it. Okay, it has a community of a lot of users where you can receive help. Okay, comprehensive statistical report. There, it is compatible with all known, operating systems. I use Windows. Most people use Windows in Nigeria. If you have Mac OS, it still works with it. If it's Linux, it still works with it. So you can go back and check some of this information. So I have to pause here and ask us, please, I need feedback. No matter how many people are able to respond, it will help me in delivering the next part of my lecture. It's possible for you not to have installed R, and then I will teach it in such a way that even if you have not installed, you'll be able to do it on your own. I can always send you materials that will help you. But I want to have an idea of how many of us already have installed R. So show by raise of hand, or no, show by typing yes. If you just go to the chat and type yes, if you already installed R and R Studio, please, let's do that like in a minute or two. Just yes. Yes means you have installed both of them. Good. Okay, so somebody is asking, how do I download it? Maybe at the end of the class, since we are going to record this video, at the end of the class, I'll put a message there. Yes, Jamu, thank you very much for having it. Yes, Ola Dotu, can you go on, sir? Oma. You are raising your hand. Is it accidental or deliberate? Obo, you want to say something, or That's an accidental raise of hands. Okay, so let's take it that some of us already have it, and that the raise of hands that I see is an accidental touch of the icon that provides that. Beautiful. Fantastic. I'm glad that there are people who have already installed it, because I expect that they will be the ones that will show others, in your office, in your place of work, how to, use it. So we have finished the first part of our lecture. What do I mean by that? We've covered some of the theory that we were supposed to look at last week, or that we looked at also. So today, even though I have this full file with you, or we have it in the classroom, I'm going to go to my R and run the code, try to explain as much as possible, because I expect that you can get this material and, read it up on your own. But the code is what is most important to us today. Okay? Then finally, when we are done, we'll come to this practical hands-on. So on that note, I'll go to my R. I have it already opened. So if you're a first user of R, if you have only R, not R Studio, this is what the interface you are going to get, this one. In fact, I can go here, I can type R. Let me see if I can get R 4.32. Let me get this out so that you can see R. So this is R. This is R. I can do 2 plus 4, and I press enter. It will give me 8. So this is R, and you can see that the interface doesn't look too friendly. But you need to download R and install R on your system, and then you can use this R, also called R base, for your work. You don't have to do R Studio. That's the first thing I want us to recognize. It doesn't mean that if you don't have R Studio, you cannot code. However, whereas R, sometimes known as R base, which is just a console, an interface, just single interface, looks like this. R Studio, for now, has this same interface, but now has 2 more environments, 2 more things. That's what we call them. So if this is what you have, and you do file, that's, just like your Microsoft Word, file, edit, and so on. So if you click on file, and you go to new file, of course, you have several options, and you click on R script. So bringing in our first word, the word script means that it is what you are going to write that your machine will run to produce a result. So if I click on that R script, it will create the 4th pane. This is where you write your code. This is your source. Recall that it was only 3. But I'm going to close this because I don't need this. Or let me not even close it. Let me minimize it. I have another instance of R that is already being used. That is this one. So from last week, we said to us that here we have the source section. Here we have the console section. When you write code in the source section, you can see the output in the console section. Again, if you create what we call a variable in this console section, in this source section, you can see it produced in this environment. This is where you get your history. This is where you get your tutorials. Here you can import data sets that exist, and you can bring in data sets that you have created on your own. Here is for presentation. You can get your files, you can get your graphs, you can get your packages, you can get help. To advise, I would say moving forward, now that you're already getting an introduction to R, you can go online download materials so that those materials can help you learn in addition. However, the cheapest thing that you can do to yourself is to go online and maybe type something like R Studio, okay, and then add image. Let's see if that will give us something nice. So it gives us this. Okay, so we can say R Studio Pens, and then we say image. And then we want to see whether we can get what. So we'll go to images, and then we have this. I think this picture looks very good and can really help us. So what am I saying? I'm saying apart from learning from us, one of the things that we will do to you is also teach you how you can learn on your own beyond having contact with us. Because really speaking, if you have learned these levels quickly, it means that the next thing that we are going to be doing will be more technical. But let's start from somewhere. So with this image, we see that this place is the source. This is the console. This is the environment, and this is the output. I think it looks like what we have in R. I think I'm convinced that it looks like that. So what did we say last week? We said in this R Studio, we can do numerical computation. You can add numbers like 2 plus 3. So if you type 2 plus 3 and you run it here, it will produce your result here, which is 5. Okay? So if you have never used R before, and today is your first time, please make sure you type that 2 plus 3, and it gives you 5. And I can tell you without missing words that you've started programming in R. Even though it looks very elementary, ordinary, but you've started. So we have close to 1.5 hours to do coding, to do, typing and all that. And I'm convinced that if we are working on our computer and we are, helpful to ask me to pause, explain again, revise something and all that when we actually need it, we'll be glad we have done, we'll be happy with where we will arrive at the end of today's session. So 10 minus 4 should give us 6. Okay, so I'll click on run, gives me 6. This asterisk means multiplication. Okay, so 6 times 2 will give me 12. 9 divided by 3 will give me 3. Now, for the purpose of those that were around last time, just to try something, I want to try something. I want to see if it will work. So with this one, we have, he's already complaining. He's already complaining. So maybe I wouldn't bother myself with that. So we have 5 to the power of 2. That should give us 25. Okay, so look at what I've written. It's giving me an error. And what does it say? It says unexpected numeric constant. That means it doesn't understand this thing that I put here. So if I go there and I change that to something else and I run that line, that'll give me a result. What have I done there? I've also shown you that it's not every time that you run a line of code, this is a line of code, that you will get an output. Sometimes it will return an error. And none of us like seeing errors. However, as we develop in this class, we will learn how to use errors to solve problems. That means when we see errors, we'll look at what the error is saying and then try to solve that problem. Because errors are referred to as bugs. They will not make your code to either function or in some cases function properly. Okay, so we need to remove the bug. The process of removing a bug is called debugging in any programming language. So never get too frustrated when you see errors, because from the errors, you have additional information, sometimes telling you the kind of error, and then even pointing to you where the error is, and in some instances, recommending to you how to solve that problem. So moving forward to line 19, we want to remind us of how to create variables. Variables are not numbers. variables are created by combining letters with numbers. You can use just letters, you can use names in letters, but you can also add numbers to those letters. However, there is always this rule that you don't start naming a variable beginning with numbers. You name variables using letters. And to help you, it's better you use words that will remind you of what that variable does or contains in the future. Because when you code, you must realize that that code that you are writing, somebody else will need to look at it sometime. And because not all the time that you are going to be the one coding alone, you are going to be solving problems with a team, a collection of people. So it is important for you to recognize that writing very good variable names will make other users understand what that variable is actually doing. Therefore, in creating our variable here, you notice that we created a variable sum underscore xy. What that variable does is what you see on the right-hand side. It adds x to y. It adds x to y. We said last week, and we can say again, that you can actually use equal to, but for R, the convention is to use less than and then that dash. So if I run line 19, what line 19 is going to do is that it's going to create a container called a variable. And inside that container, you have the number 5. So if you run that, we have created 5. And here it says 5 has been created inside the container called X. If we run Y, Y is created containing 10. If we run sum underscore XY, sum underscore XY has also been created. But now, this variable can now be called a composite variable or a derived variable in the sense that some XY must go and look for what is in X and then add it to what is in Y. So if I ask it to print some XY and I run that line of code, it will tell me 15. However, if I change that to 50 and I come to this line and I say print, it will still give me 15 because even though I put 50 here, I've not run that line of code for X to change because X is mutable. What it means is that if I now run that line of code, it now takes in X. It says X is no longer 5. Now I know it's 50. So if I now run the next 2 lines of code, my sum will now be 60 because now it has now wiped off the previous 5 to 50. I hope I'm making sense. So if I make this other one to be 100 and I run that line of code, it tells me now that Y is no more 10. And if I ask it to print Y here, it's going to print Y for me as 100. I hope you are following. As you are watching these lines of code, also watch the output where we have the console. So again, we don't only use numbers. There are other things we use which we are going to see later. I'm doing this deliberately. For some of us, it might appear as repetition, it might appear redundant, it might appear as waste of time, but we just have to do it for the sake of those who have just joined, and because we know that it will reinforce the learning. We won't do this next week, and hopefully we'll cover what we have this week, okay? But we needed to do this. So pardon me if it's sounding like, oh, repetition, but that's not all that we are going to do today. So we have seen creation of numbers. Now I want to talk about vectors. And let's do a little bit of maths if you have love for maths. So we have what we call scalars and vectors. Scalars are usually single values. Okay. So for us in this particular context, scalars are single numbers. Okay. Scalars are single numbers like 20, 40, occurring separately. But vectors are now collection of scalars. So here we have 5 scalars, numbers 1, 2, 3, 4, and 5. And together they are called vectors. To create a vector, we use a function C. So putting that C in front of that parenthesis creates for us a vector. So here we have scalars 1, 2, 3, 4, 5. With the parenthesis and this C, we have created a vector. We now put that vector inside the variable called numbers. So what we have done here is created a variable called numbers, but inside that variable, we created a vector using the C function. And inside that vector, there are 5 numbers each of them scalars. So if I run that 29, it will store variable called numbers. And then it will tell you I have a variable called numbers. The numbers are numeric. They are from 1 to 5, and these are their values. So there's a lot of communication that happens here. And that's our goal in this class. It is not just for you to be able to copy code and run code. And that's why some of us run away from some tools that everybody knows. It's a shame that I don't know how to use SPSS because I've never learned it. When I did statistics, we're not using calculator, we're really manually calculating. And then SPSS came and I wasn't in school. And now I don't know how to use SPSS, but I can use R to do what SPSS does and even more. The difference between this and SPSS is that this one is dynamic. You can actually create your own functions, your own variables, your own solutions. We'll get there. So if we come to line 30, what we are doing in line 30 is that we are running down numbers. We want to see what is in the numbers. So it goes there and tell us, yes, there's a variable called numbers. Inside it, we have 1, 2, 3, 4, 5. Same thing if we use print, makes not much difference. After vectors, we now have matrices. Don't forget, scalars are single values. Vectors are either rows or columns of values. But when you now have combination of rows and columns, then you have a matrix. Okay? So the example of matrix we have here can be created by using a matrix function. When we're creating vectors, we use the C function. But for matrix, we use a matrix function. And then we mention here the numbers that we want to begin from and end at. Meaning that we are saying we want numbers 1 to 9. Start from 1, end at 9. Therefore, we say I need 3 rows and 3 columns. But the question is, can I create another matrix? Let me call matrix underscore 2. And then we do that, put that, use our matrix function just to show you something. And then we want to go from 1 to 8. And then we say number of rows is equal to 4. And then we say number of columns is equal to 2. Why does this make sense? Because 4 plus 2 must give you 8. If it doesn't give you 8, then it will not be compatible with the number of items that are inside that matrix. So what was I doing here? I was going to write 4 here and put 2 here, and then call this matrix 3, just for you to see the difference. So we'll go. So again, even though we are revising last week's lecture, I found a way to introduce a little more, new information that could excite some of us. So here we have created 3 matrices. The first one is matrix example. The next one is matrix 2. The third one is matrix 3. So what I would do here is, just allow me. So I'm going to call this matrix 2, and then I'll call this matrix 3. I want you to see the differences. So let me start running from matrix example. So I'll run that line of code, and then run matrix 2, and run matrix 3. What I've done is I've created 3 matrices. Okay, you see. Let's now print. Print the first one. See the matrix here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Very important. See the next one. There are 1, 2, 3, 4 rows. 1, 2 columns. Let's try the third one. 1, 2, 3, 4 columns, 2 rows. So this specification that you give here actually determines the order of the matrix, the structure of the matrix. Brilliant. So we have moved from scalars, single values, numbers in this case, to vectors, rows, to columns, rows and columns together, to data frame, which is the goal. Is this data frame that's our target? Creating a data frame by ourselves, or having to be able to interpret a data frame created by somebody else. So we want to call this data frame. For vectors, we use a function. For matrix, we use matrix function. But for data frame, we use the data.frame function. Now, because the data frame will have rows and columns, and we are the ones creating it, then we need to have labels for each of the columns. Labels for the columns. Labels for the columns. And then you have items in the rows. So the first column will now be name. We create a vector of 2 individuals, Alice and Bob. We say, okay, what other column do we need? We need age. We create values there, 25 and 30. The number of items you have here must coincide with the number here. Otherwise, it will be inconsistent. When you run, and you print out the variable data frame, you are going to have Alice is 25 years, Bob is 30 years. So let me run that line of code and the next one. And then you see our table. Alice is 25, Bob is 30. Okay, can we go on? Yes, I suppose. Can we go on? Yes, I suppose. Yes, from me, yes. I hope from everybody. So at this point, you are supposed to, perform an exercise, open RAW Studio, do some basic computation, create a variable, and do some exercises on vectors. So let me now go to the class and ask us, did anybody try to do anything and you want to share with us? Did we just mention to us, did you attempt anything over the past week? I need 1 or 2 people. Of course, the class is going to be more interactive than now in future lectures. It's because right now we are trying to set the pace. That's why we are, just teaching and, showing you things. In the next 2 weeks, it will be real hands-on, and then there will be back and forth conversation. Anybody wants to say something from the practice you did during the week? Akim. Hello, Akim. Okay, Akim is not saying anything. HOD, my brother, you want to say something? I just want somebody to say something, and let me just continue. Actually, this is not my best way. My best way is when we are interacting and talking, but at this point, that's not what we should focus on. We should focus on making sure that we cover the content. Okay, since nobody is saying anything, who wants to rescue me? Somebody should just rescue me and tell me that. Hello? Hello? Hello, Dr. Akim. I can't hear you well. I'm looking for somebody to tell me what he did last week, during the week, even if it's installing the software. Dr. Adimola?
Yeah.
Yes. Did you do anything? Did you do anything?
I only want to ask.
Yeah.
You promised to share us the last lecture.
Wow.
I mean, the recorded lecture.
Wow.
We didn't get that.
Wow. My bad. Sorry about that. Sorry about that. We will, I'll discuss with Prof. I'll search for it. But this
And I
one,
hope even this one, you're going to share it to us.
yeah. I'm recording deliberately, and I can search for that one too. Don't worry. Yeah. But thank you for saying something. I wanted somebody to just say something. Don't worry. I'll do my bit. Okay. So let's go on at a much faster pace. So here we have character vector. Remember that the vectors we have looked at so far were actually numbers. So we are now saying that we can also create vectors using letters. But when you use letters, know that you have to put them in quotation marks. So here we have a character vector, which is made up of 3 numbers, 3 fruits: apple, banana, and cherry. And here we also have another vector describing another data, structure, which we call booleans, logical vector, true or false. So if we run line 55, it will create the character vector, store apple, banana, and cherry inside character vector. And if you do logical vector, it will create logical vector as a variable and store true, false, true there. And then when you run the line, it will tell you, okay, you want me to print out what is in character vector, it gives you apple, banana, and cherry. And when you say print out what is in logical vector, it tells you true, false, false, or true, false, true. Okay, how then do we assess elements, locating elements? Okay, so elements are written in terms of numbers. So if we go back to our num vector, let's look at num vector. If you look at num vector, you will see that, where is that one? Or let's jump. I think that can happen last week. Let's jump this num vector. Let's not bother us. Let's talk about this character vector. Notice that the character vector has apple, banana, and cherry. So apple is in position 1, banana is in position 2, and cherry is in position 3. So if I write character underscore vector, it goes to check this vector and returns the element that is in position 1. which is apple. So if I run line 64, my output will be apple. If I run line 65, it will go and check character vector, look for the element that is in position 3, which is cherry, and then it will print it out for me. So the next one will be cherry. Okay? Then we introduce another kind of data structure called list. Okay? So list can be created by using what we call a list function. So we'll keep having different functions. So yeah, we want to create a list. We said call that variable my list. Inside the variable, create a list function, but let that list have the following features. First, name, separated by comma, age, separated by comma, and then scores. So we have the variable, the feature, and the value, feature and value. But when we now come to scores, we now have 3 values. These values are the scores for this individual. So if I run line 76 and run line 77, I'm going to get my variables. Name is John, age is 30, and the scores are 80, 90, and 85. Having done that, I can now target specific features. How? If I want it to print out John's name, that's what I want. I just want John. So I will go to my list. Inside my list, I will target name. And what am I going to use to combine that? I'll use this $ like you use in Excel. This is going to be occurred today, later in the third part of our class when we are looking at pre-processing. So this is going to target name. And when it gets to name, it's going to return John. So if I run line 80, okay, so why is it saying, is it because I tried to highlight John? So if I say my list $name and I run that, it will give me John. If I do my list $scores, it's going to give me all the scores. But watch this. If I do my list $scores square bracket 2, what it's going to do is that it will go to my list, which is a variable, check for the feature that is scores, and look for the value that is the second one. Remember, the scores are 80, 90, and 85. If I did not put this square bracket, it will give me all of them. But if I put square bracket and put a number there, it will target the second element. So my output will be 90. Let's move on. So if we do the same thing with matrices, and we create the kind of matrix that we have created before. Remember, we have seen this matrix before. So trying to remind ourselves, okay? Then we need to understand that these things here are very crucial. Here, it says this is column 1, because matrices are named by row and column. So if I say a matrix is a 4x5 matrix, I'm saying it has 4 rows and 5 columns. So anytime you see this square bracket and you see only a single number, that single number might be referring to the row or just the column. If it is referring to the row, it will be the first number before the comma sign. If it is the column, it will be comma the next one. Now, when you see this, it means that give me the whole of row 1. If you see this, it means give me the whole of row 2. If I do this, it says give me the whole of row, If you say this, the whole of column 1. This one, the whole of column 2. Here, the whole of row 2. So if I ask it to do this for me, my matrix, square bracket 2, 3, it will look for row 2, column 3. So it will go to row 2, this entire row, and then get the column 3, which is this 8. So this line of code is supposed to give us 8. If I go to line 97, this one will give me the whole row. But which column? Column 1. So I will go to column 1, and it will give me everything in column 1. Let's run that line and let's see whether we'll get 1, 2, 3, which is everything in that column. Wow. How the Balogun is presenting. Somebody else presenting screen. So I will run this line of code. They are no longer presenting. Is my screen gone? Hello, is my screen gone?
Yes.
Wow. My screen is gone. So you can't see my screen again.
We don't see it. We can't see
Your
it
screen is
again.
gone.
Somebody was trying to present screen and the screen was superimposed on my screen.
Your screen is back.
Thank you very much, sir. God bless you, crew. So we're doing R. Okay, so here, line 99, line 97 gives me the column 1, 2, 3. Line 99 gives me the row 1, 4, 7 because it's row 1. So this output will be 1, 4, 7. So we have seen matrices. We have seen how to retrieve, data from a matrix. What about from a data frame, which is the most significant, data structure or data type that we are looking at this stage? So what have we done? We have created a data frame. We want to call that data frame students. So we are looking at students in this, maybe this, or let me put my friend there, Dr. Ademola. Who else is in this class that I can put? Want to have your name here? Anybody? Please, let's try something. I want to change this data frame. Anybody wants name here?
Put Dr. Olubode.
Okay, Dr. Olubode. Hey, wow. Don't mind my spelling. And let me put my name. So we are in the same class, the three of us. I don't know your ages, but let me assume that Dr. Ademola is 53, Dr. Olubode is 57, and I'm 21. And then we did a test, and then Dr. Ademola had 85, Dr. Olubode had 90, and I failed the test. Too bad. So if we run this line, we'll create a data frame of students in my class or in someone else's class. 3 students whose results are there. So you see, with this code, you can actually, begin to generate data for your courses, your students. Okay? You can generate data for a department. You can, on your own, just sit down and create data. It could be data from anywhere for anything. Actually, it's better to create data that solves problems. So maybe you've been struggling with trying to get the marks of your students limited. And then you want to also use machine learning methods to predict the scores of your students in the exam based on their attendance and their responses in class. That could be a problem. I'm just thinking on top of my head. And then you want to capture data in a class, and you want to, at the same time, teach your students R programming. Then you can ask them to mention their names, and then you get their names, maybe about 50 of them, get their ages, get their gender, get their state of origin, their addresses, and keep, building up that data set. And in the end, you can turn this to an Excel sheet or even use it for data science, machine learning, AI, and all of that. That would be very interesting. So the goal of this class is beyond just acquiring the knowledge. It's also about using it to make your work better. So if we print students here, would have created, you see that what we had before was different. And then if somebody is not happy that you didn't put my name, let's now assume that, is anybody here? And because we have only put the names of men, let's put the name of one woman. Anybody is a female. I think I saw something like Felicia. So I can say doctor. Now I'm writing doctor and it's complaining. Why? Because I didn't use quotation marks. So I can now do Dr. Felicia. She just joined. Of course, there are different ways of adding. But for now, let's just say she's the genius. But she's also very young like me. Let's say she's 23, youngest doctor in Federal School of Statistics. And she did this and got 99. I said, wow, there's a new person in God. And then if we run that, and then we run, finish everything out, we've added an extra person. But this method is not decent. So we need to learn, more ways of adding newer data. So now if we want to capture in a data frame, we only want the names. So this line 116 goes to look for the data called the variable called student. The variable called student. Which variable is a data frame which has row. And when you run that, it's going to give you, says there's a big problem because I only highlighted it. So, but if I highlight the whole column, it tells me, okay, I have Dr. Ademola, Dr. Olubode, and Dr. Felicia. Okay, so I'm going to cancel this. And the next question is, what if I write student square bracket 2, comma, square? Who wants to help us? What will be the output here? See the data frame here. What do we expect? Let's go. Anybody wants to help us? What do we get? Somebody's microphone is on. Please. I might not be able to check your responses.
Mute yourself.
Yeah, I might not be able to check your responses, but I'll be able to hear you. Put on your mic. So look at this next group, line 118. What will be the result? Student square bracket 2, comma. Anybody? Please, somebody has to say something. What do you think this line will give us? Anybody? Okay, let me explain. If nobody is saying, because we are recording, so nobody will want to say something that is wrong. So we'll go to the student, variable that we have created. We will look for the second row. The second row is Dr. Olubode, and we're supposed to get everything in that row. So let's run it. So it's because I highlighted 2. That's why I give me 2. But if I run the entire row, it will give me Dr. Olubode 57 and 90. But if I do line 121, it will go to the third column. Okay? I can go up and check what is the third column. The third column is, the first column is name, the second column is age, and the third column is score. So if I run this, I will get the scores. And the scores are now 85, 90, 18, and 99. So this is how far we went last week. And that's the, halfway of our lectures, of today's lecture. But the things that we are going to build on top of this are no longer difficult. I'm more comfortable now. If you already understood what we have said, if that's what we have done, if it's okay for you, then we are good to go. So you see, when you have your data sets, they have different kinds of variables. They come in different shades. But the 2 important ones are numbers and letters. Okay? So whether you have numbers or letters, data can be numerical, okay, or categorical. That's how we're going to describe them. So numerical are numbers, continuous values. But categorical are discrete. You can put them into different classes. So gender is an example of the categorical data. And at the end of the day, that kind of data is going to have levels. Therefore, for future analysis, it is important to convert the categorical data that have levels into factors. We are going to see that as we continue. How do we convert categorical data into factors? First, we give it a name. Here we are using the name gender. We now assign by using the factor function. Okay, but that factor function is built on top of your vector. Your vector is the list. So if I run line 126 will create a vector. Okay, so it's because I highlighted C. So if I highlight everything, it will create this gender variable, which is going to be converted into a vector, okay, using factor function or building factor on top of vectors. So if we now print gender, you are going to see that apart from giving you the output, it's going to tell you that there are two levels. The levels are female and male. But if it's only the levels that you want to retrieve, you just use the levels function. And what does it do? It tells you the unique levels, female and male. Moving forward, some quick arithmetic operations which we have seen before. I'm just going to read through them. So created A, which is 10, created B, which is 5. We add 10 to 5, we get 15. We add 10 minus 5, 5. The product gives us 50. The division gives us 2. And then the exponent. Wow, big grammar. Okay, so if we print sum, to add the two numbers, 15. Difference, 5. Product, 50. Quotient, 2. Exponent, 50. Why? Because we have used asterisk here. It's supposed to be the caret symbol. Let's confirm. So if we now run line 140 and we scroll down to line 146, we should get an interesting number, which is 10 to the power of 5. Okay, exponential function. In the same way, we can now have two vectors. So far, we have seen just one vector. Now we are seeing two vectors. Vector 1 is x, containing 3 values, 2, 4, and 6. Vector 2 is y, also containing the same number of values, 1, 3, and 5. If we now sum, the way it's going to sum is that it's going to sum corresponding elements. At this point, we have to slow down a bit. So here, it will add 2 and 1 because they are occupying virtually similar positions. And our output will be 2 plus 1, 3, 4 plus 3, 7, 6 plus 5, 11. So let's first create a variable called sum underscore xy. And when we print it, we'll have the sum 7 and 11. Moving forward, because some of these texts are going to say are crucial. They might be a bit mathematical, but please feel free to interrupt me because we are looking at data science fundamentals using R. So beyond today's lecture, we might run away from R programming, as it were, and focus on data science. So the bulk of what we are going to be doing will be data science, data science, data science. But there are certain, preliminary or foundational knowledge that you need to have in programming, one of which is understanding logical operation. Please, if you don't agree or you don't understand, feel free to stop me because here could be a bit technical and sometimes controversial. Please allow me to be able to be sure that we have communicated this. So line 157, we create a variable x and the value is number 10. Line 158, variable y, the value is 5. Then line 159 says x greater than y. Is it true? It should be true because 10 is greater than 5. So if you run line 159, the output is true. So that's where logic now comes in. And logic is one of the strengths of programming. Wow. When you can write logical statements and you introduce it into your code, your program, then it becomes more efficient. Line 161, double equal to is the logical operator for equation. So if I say, let me try something. If I say, say D is equal to T, this is not true because D is supposed to be equal to a value, not another variable.
Sir, omit.
Yeah. Go on. Anybody? Can I go on? Can I go on, please? I need help. Somebody was saying something. Wow. Can I go on, please? Okay, let me go on. So D is equal to Alice, one equal sign is saying that Alice is inside D. D is a container, D is a variable. If you get inside D, you will see Alice. That's what line 162 says. But this new line 162 says the left-hand side and the right-hand side are the same. So if I run line 162, it will either say true or false. So question, what is in X? X is 10. What is in Y? 5. Is 10 equal to 5? It says false. 10 is not equal to 5. But if you now go to line 164, this exclamation mark means not equal to. So I can put hashtag here and do double equal to, and I'll say means equality. Okay? And then I can come to line 164, put hashtag, and say exclamation mark means inequality. I hope this should help. So when you have double equal sign, it's equality. When you have exclamation mark and equal sign, it means inequality. So if X is 10 and Y is 5, and I say X is not equal to 5, then it means that statement is true. That's why this output is true. Just one more. Let me see. If I create a variable A and I say A is 10 to the power of 2, and then I say B is equal to, how will I do that? 2 multiplied by 51. And then I now say A is equal to B. A is greater than B. What will I do now? A is not equal to B. There was something that's coming to my mind. Don't mind my mind. My mind is always thinking some very interesting thing. So A is 10 to the power of 2. And B is 2 multiplied by 50 or 51. So class, what do we expect in line 170? A equal to B. Is it true or false? Please rescue me, at least one person. Okay, let's just go on.
False.
False, false. A is not equal to B. False. Is A greater than B? A is 100. B is 102. False. Is A not equal to B? True. A is not equal to B. So you can use this logical statement to do a lot of beautiful things. Then you can even combine those two logical statements. So in elementary maths, 100 level, 200 level maths, you know, logic and numerical analysis, if A is true and B is false, A and B will be false, because false and true will be false. The only way when you use and, by the way, this ampersand means and. Maybe I should put that there. I'll do that. I'll put, where is it? Ampersand means and. And then this other one is called a pipe. So I'll say pipe sign means or. So here, when I do A and B, true and false, give me false. Line 177 will give me false. Line 179 will give me true. Because when you take true and false, you only need one of them to be true. And then line 181, not false. Not false. They tell us why A is true. A is true. So not true is false. The opposite of this thing means, let me no, somebody's phone is computer means not not A. So not A, because A means true, not A should be false. So at this point, we could have done another exercise, but we have spared you that. So we'll go back to some of the things that we have seen before so that we can begin to move into more advanced concepts. So we have seen numeric vector, character vector, and logical vector. This is just a way of reminding ourselves. But we can create other newer vectors. Somebody's computer is affecting us. Hello. Hello. Amina. Amina, please, can you mute? Hello. Wow. Well, let's keep going. Let's keep going. So let's go on. So in line 208, we have created a vector. Remember that we use the C function to create a vector. And in that we have the numbers 1, 2, and 3. So if we run that line, we have created vector 1. If we run the next line, we have created vector 2. If we now run some vector and we write on the right-hand side what we want it to do, we are going to be adding 1 to 4, 2 to 5, and 3 to 6. If you put asterisks, we are going to multiply the numbers, by each of them. So when you print out line 2212, you have 1 plus 4, 5, 7, and 9. And when you multiply, you have 4, 10, and 18, I think. So let's see whether we'll get those values. And then you see that we have 5, 7, and 9 additions. Then product 4, 10, and 17. No, and 18, sorry. 4, 10, and 18. I hope you are making sense. So what about assessing vector elements? Still the same idea. Once you have a vector and you put a value there, it goes to pick the second value. That's what it does. And if you have character vector, it goes to pick the second value. That's what it does. So we'll pick 2 there, and then in the next line, I think we'll pick, is it apple that we'll pick? Because it's the first element. So are we able to modify vectors? Yes. We can add elements to vectors. Are we able to remove elements for vectors? Yes, we can. So let's recall our vector. We had a vector named my vector containing 3 elements, 10, 20, 30. We now want to add a new one. So what do? We create a vector, name our vector, and then put a value there. I'm going to run this line of code and then show you the next line so that you can capture it. So I'll run line 226 and 227. We have more elements, but to buttress it, I think we have what we called my character. Yeah, let's character vector. Where is it now? Character vector. I want you to see it. So if we do character vector, I want us to run that. Good. Good. So if we come here and we run character vector, and then we want to modify it, we will now rewrite character. Hello, somebody wants to say something, please go ahead. Character vector. But what we will do now is we have our C function, and then we now name the variable, which in this case is our character vector, and then we add a new item, which can be maybe purple. Okay, so if we now go to the next line and we ask it to print, character vector, I'm writing this fresh so that you can see that, oh, it really works. So in line 229, we have a variable called character vector. Inside that character vector, we've added a new, item, which is purple. So when we now run that, we have that new added to it. So we can actually add. We can also remove, okay, by locating the position and then we use a minus sign. So it goes to remove the second value. Okay, so if we can go back and then first write my underscore vector so that we see how it looks like. So my vector is now 10, 20, 30, 40 because we have written that. And then we want to remove 20. We create my vector again, but we say remove the second value. And by the time we check the print, 20 would have disappeared. And then we have 10, 30, and 40. Looking nice. Then we can also replace, for instance, we want to change that last element, which is 40. We want to change it to 100. Okay, you know, we added something, this 40. We want to change it to 100. Okay, but we've removed, so it cannot be number 4 again. It will now be number 3. You know, we have removed one of it. So if we run line 239, okay, we are going to have 10, 30, and 100. What has happened? We have removed 20 and we have converted 40 to 100. Moving forward, we can now do our matrix again, just as reminder. This is just like rounding off last lecture and going back to some of the things that we have seen before. We can get the dimension of the matrix to know how many rows and columns. And like we have said, I can even remind ourselves, I don't know whether you remember, that we actually had a matrix. We call it is it my matrix? Is it in today's class? Matrix example, matrix 2. Brilliant. So we can look for the dimension of matrix 2. And I think it was 4 by 2. And then we have 4 by 2. We also had matrix 3. But if we go back to my matrix, which is this one here, this is my matrix. I hope you can see my screen. 1, 2, 3, first row, 4, 5, 6, second row, 7, 8, 9, next row. And we now want to extract elements. What we want to pick here is we want to go to row 2 and column 3, which we have seen before. We want to capture this element 8. But I don't want to do that. I want to do 3, 1. Somebody to tell us what this is going to retrieve. What is this going to retrieve? Line 260. It's getting hot here now. Somebody tell us. This is the matrix here. 1, 4, 2, 5, 3, 9. And I want to get my matrix 3, 1. I promise that it will be interactive. So now it's getting active. Yes, go on. Just unmute and tell us your answer. Hello? Hello? Nobody wants to build.
It's going to give us 15 and 12.
It will give us what?
It's going to give us 15 and 12.
It's going to give us 3. No, it will give us 3. 3. Because it's in row 3 and column 1.
Column 1.
And then this one will give us the whole of column 1, which is 1, 2, 3. This one will give us the whole of row 1, which is 1, 4, 7. Okay? Then we can do matrix arithmetic. How? Let's look at this very interesting situation. We want to create matrices. I'm in line 269. I want to create matrix A, and I want matrix A to be the numbers 1 to 4, built in the form that I will have 2 rows and 2 columns. I want to create another matrix B. I want it to go from 5 to 8, which is 4 numbers. I want it to also be a 2 by 2 matrix, and then I can print each of them. Let's see. 269, we have created the matrix. 270, we've seen the matrix. 1, 2, 3, 4. 271, we created the matrix. 272, 5, 6, 7, 8. We want to add. Do you know how it's going to add? To add 1 to 5, 2 to 6, 3 to 7, 4 to 8. I hope that makes sense. So let's see the sum. The sum will be 1 plus 5, 6, and so on. And the product, it will multiply tier-wise. However, in terms of real matrix multiplication, the story is a bit different. So I will go and then get a whiteboard. Call this whiteboard online. Can I? Yeah. So that we can recall matrix multiplication. Okay. The good thing is that if you have small matrices like 2 by 2 matrices, you can actually do them manually. But what if you have real matrices, which are large matrices? There are a lot of networks that you have, which come in those forms. So let's do a simple one. Let's assume that I have a matrix A. And in that matrix, I have 2 by 2. 1, 2, 3, and 4. This is a matrix. And then there's a matrix B. And my matrix is 5, 6, 7, and 8. If I want to do matrix multiplication, I will first multiply this row by this column to get one element. I'll say 1 times 5, then 3 times 6. So 1 times 5 is 5, 3 times 6 is 18. So multiplication of matrix A by matrix B will produce for me 4 elements. But the 4 elements are going to be derived by a very clever way of multiplying. Row 1 by column 1. 1 times 5, 5, 3 times 6, 18. 5 plus 18 will give me 23. First element. Next element, row 1 by column 2. 1 times 7, 7. 3 times 8, 24. 7 plus 24, 31. I'm done with that row. I've used 1 and 3. Then I'll come to row 2. Row 2 times column 1. 2 times 5, 10. 4 times 6, 24. 24 plus 10, 34. And finally, I want to multiply this row by this column. 2 times 7, 14. 4 times 8, 32. 32 plus 14 looks like 46. So, if this is true, I will now come here and do this matrix multiplication. We are supposed to get 23, 34, 31, 46. Let's confirm from our online board. 23, 34, 31, 46. So what we are saying is, with this simple, structure, it looks easy. But when the matrix becomes larger, then you need help. So what do we do? When we are doing normal product, we just use asterisks. But when we want to do proper matrix multiplication, we use this percentage, asterisk, percentage. So while this asterisk gives us element-wise multiplication, this percentage, asterisk percentage, gives us the real matrix multiplication. We are back to, 100 level, year 1, SS3 stuff. So we'll go back and remind ourselves of some of these things which we have already done so that we don't waste much time. We print that, and then we want to check the structure of the data, which is something that we have talked about. And then, importantly, we can do a summary statistics. That summary statistics will give you the list value, okay? And you can see that the values you are getting here are values based on initial data. But if we go back up, I think I remembered that we played with one where we added our names. We added more names. However, let's not bother ourselves so much about that since you are going to have this file. So by using this summary function, data analysis has begun. This is part of exploratory data analysis. By the time we take this just this summary function and we apply it to our variable, it gives us this result. And we can say that at the end of the day, the minimum age is 21. The lower quartile is 21.5. Median age is 22. Mean is 22.3. Third quartile is 23, and maximum is 24. Okay, so this is easy because we just have these 3 data points. It will do the same thing if you even have a bigger data set. So it's good to start learning, with these simple ones. So it does the same analysis for age and goes on to do the same thing for scores. Okay, so like we said, we can retrieve name, we can retrieve positions, and we can retrieve rows. Okay, so we could also want to find out whether a student passed or not. That's, you are trying to modify your data in the sense that you can set a threshold. Okay, so this becomes important for those of us that are lecturers. I will still come back to this. We'll do this again and again. This is what we are here for, to do analysis. Okay, so data science, inside data science is subsumed what we call data analysis. So it's going to be there. But what we are saying is at the end of the day, you have your mark sheet of about 200 students, and you decide that your pass mark is 40%. I want to check how many students passed. And you found out of 200 students, only 50 passed. And you feel like, adjusting the marks so that more people can gain marks. You can do it programmatically, and then you can award everybody 5 marks. Or you can even do it in a better programmatic way and say, okay, I'm going to use attendance and look at how well they attended the class. And then you code your program in such a way that it will award more marks to students who attended the classes more. These are some of the things that we are going to learn as we go on. So we want to see students that passed and all of that. And then even those that, did not give us a value. So some of these things are part of the things that we're supposed to see last week. So last week's lecture is gone. We have 30 minutes to do this week's lecture, which is not a big deal. The reason why it is not a big deal is that we've said so much that will make this week's lecture quick for us to understand. Let me pause for like a minute and allow you to take 2-3 minutes break, and then we'll be back in 2 minutes. Let's take some water. 2 minutes. And I can pause. Can you pause recording? Is there a way? Oh, no, I can't pause recording. No problem. Let's just take that 2 minutes. Doesn't matter. 2 minutes. So welcome back, everyone. I know that that time would have been very short. Sorry about that, but you're almost done. So let's come to today's lesson. Can you still see my screen? Hello, can you see my screen? Hello, am I talking?
Yes.
Yeah. Thank you. Let's go to our class and get our material for this week. So this week, we are supposed to be looking at data wrangling. Remember that last week, when we looked at the steps, can I go on? So when we looked at the steps in the data science workflow, we said that the first step is for you to understand and define the problem. Then the second step is to collect data. And then the next step we said is about cleaning the data and pre-processing. So what we have in data wrangling is cleaning, structuring, and enriching raw data into a desired format for analysis. So today's session is about having data and trying to transform the data, okay, by cleaning up all those issues in the data that will not allow us to get accurate results. What does it do? It helps us to have accurate, predictions, forecasts. Then helps us to make better decisions. Okay, we are also able to capture all the data points for completeness sake. And then we can have that data that somebody else can reuse. Why would you want to give somebody raw data? If not that you just want to teach the person how to, wrangle, format, restructure data. If that's not your goal, you'll be better off giving somebody data that is already cleaned. So what do we do in data wrangling? Not, too many things, as it were, but very essential things. One, we can read and write data. That means we can have data and be able to get the content in it. And then we can create our own content. So that's the reading and writing. Then in data wrangling, we can clean up data, as we have said, and we can change the structure of the data, which is transformation. One of which is, we're looking at factors in the other lecture. Then we can also subset it, break it into small units, pick some aspects of our data and work on it. And then we can filter out some sections. So there's subsetting and filtering. And then we can change the shape. Remember that when we were looking at matrices, there was this example that I gave us, and I said four rows, 2 columns. And then in the third one, I said it's 2 rows, 4 columns. So it's possible to reshape the structure of your data and then, summarize and bring out information from your data. So by changing the orientation of your data, you can actually get more insights. So we'll begin by how do we read and how do we write in R? Because this issue of data wrangling can also be done in other programming languages. But we are using R programming language. So what do we do? How do we read? Okay, so what R does for us is that it gives us functions. Remember functions again. We've seen so many functions. We've seen C functions for vectors. We've seen matrix functions and so on. Okay, so if you want to read a comma-separated file, a CSV file, R has a function called read.csv. So read.csv is the function that you need to write to be able to read a comma-separated file. If you want to read an Excel file, okay, then the function that you will use is read Excel : read _ Excel. And I've said in our previous class, for those of you that are now, let me tell you what I said. I said you don't have to know all those functions by heart. You just need to look for them when you need them. If you know them, good, bonus. So if your data, if the extension of your data is XLSX, then you read this function to read it. If it is .csv, then you read this function, use this function. So that's easy. Just applying the right function in front of your data set, reads it. By the way, your data set should have quotation marks. I just wish that we'll get to where we'll demonstrate. If we demonstrate, that will solve a lot of problems. Okay, good. Now, what about if we want to read a text file, maybe like an essay, a passage, a story? Then we need to use the read.table, but then add some extra parameters, 2 of which are, we want the headers to be retained, and we want the separation to be by tab. You know, because it's a text, if you write, I am a good boy, there's a separation between I and am. That separation is what this T takes care of. Okay, so this T shows that every time you put a space between a letter and another letter, it means that there are two different existing words. I am a boy contains three words: I am, then boy, and they are each separated. Even though I is a letter, well, interestingly, it's also a word. So when you are reading text, apart from getting the file name, however, this file might be located in a folder. We are going to see that later, but you need to add these extra arguments. So this argument either is true, and the separation method is tab. That's what that T stands for. What do we do when we want to write? Instead of writing read.csv, we are going to say write.csv. Then where do we want to write to? That same data set that exists, that variable name, and then you now give it a name that you want. It's you that will now write this name here, because you are the one creating. It's like writing a disc, maybe producing a film. Once you are done writing your essay, you are the one that now determines the title of the essay. But when you are reading, you are not the one who has that title. You are actually importing an existing title. That's why this is what you expect it to print. Do I want the row names? No. Why would I want to have the names for the rows in terms of number and all that? I wouldn't want that. I hope my screen is not off, because I can see someone also trying to share screen. So this thing says that I'm no longer presenting. Is that true?
Yes, sir.
Okay, so it was somebody who attempted to share screen, and then that's now,
It's
over. Yes, it puts me out. Bad. So let me try again. Resume presentation. I just hope that we are making progress, because these initial lectures are sometimes the most important ones. So don't forget, when you are writing, you use write.csv. In the same way, write.table. Okay, we are going to demonstrate this later. Okay, so we want to now explore data. We want to see what is in our data. We want to check what is in it. What is even in this data? Then we can use the str function, which gives us the structure. It tells us the variables and their names and their types. And then the summary function gives us those things that we saw earlier, where we had mean, maximum, first quarter, middle quarter. Moving forward, we have another amazing set of functions. What this one do is that they show us the first few rows. So if you use head as a function, it shows you row 1, 2, 3, 4, 5, 6. And if you use tail, it shows you the last few rows. We are going to demonstrate it. Moving forward, we can check for missing values by using this function. We want to count how many values are missing. And we are going to use is.na. Okay, so is.na helps us to look out for the null values, to identify them. But if we put some outside, he adds them up and says, in this data set, there are so numbers of missing values. So move on to data cleaning and transformation. What do we do in data cleaning? We remove missing values if we need to, or we replace them. So there are things that you can do to missing values, which are things that we'll see later in this lecture. So in data cleaning, we can remove missing or incorrect and duplicate values. We also ensure that there's data consistency in preparation for data analysis and visualization. So how do we perform this data cleaning? We are going to be looking at handling missing values, making sure that our columns are standardized, and converting data types from one shape form to another. And in addition, removing duplicates. This lecture is such that it is just to show you those functions and then we implement them. That was why we said that we needed to revisit that first lecture, ensure that we are properly grounded in that first lecture and we have a good grasp of it. These other ones are just introducing functions. Don't forget that these are still preliminary topics, but when you know them, you are already well positioned for the more advanced or latter topics. So how do we identify missing values? We identify missing values by counting them and applying this function that we have said before. But again, missing values can be found in columns. Okay, they might not just be missing in the rows, they can be missing in columns. So we now use sum of the columns and get the missing values. What do you do to missing values after you have identified them? Do we throw them away? If you can't throw away missing values, if you throw away missing values, you either need to throw away the rows or the columns because missing values are found in rows and columns. So what do we do? Best way. Of course, we can remove the entire row if need be, but one way is to replace them. How do we replace them? Do we just replace them arbitrarily and just say, okay, this value is missing, let me just replace it? No, that's not what you do. What you do is first, you identify the row where the column where the value is missing, the feature, the variable. For instance, if it is age, remember that age is numerical, number. So one way to replace age is to find the mean of all the ages in that column. And then wherever numbers are missing, just put the average there. There are other techniques, but that's a very good technique. But again, what about if it is not age? Then you can insert the mode if it is categorical data, okay? Or if it is data that is not numerical. So, but in this example, we can replace by inserting mean. How do we do that? We go to age, okay? And we say anywhere we have age, apply missing values. We are going to check this later. So it says here that you can remove the entire row by using the function na omit. This will do what? It will go to any row where there is missing values and then pull up that entire row. That's what that line of code does. So here, standardizing common column names. Yes, we have column names and we want to make them standard. Again, just like we did last week, which is not really a big problem because we are still going to be here together. I wouldn't want to complete these notes without reinforcing the things in the notes that we have seen. So I'm going to move away from that PowerPoint and then implement a few things, okay? In terms of data wrangling, because I want to send this file to you, I'm more concerned about sending this file to you. And I actually want to see if I can get to the end. In 10 minutes, that might be difficult, but let's see how far we can go. So let's talk about what we are going to do next week. So next week, we are going to introduce a new topic. But before we go to that new topic, we will complete the latter part of today's lecture. But please just relax and watch the next 10 minutes. It's going to contain a lot of things that could sound strange, but it's important for us to touch on it so that there'll be something new that we have learned today. So before you proceed to reading data and writing data and all of that, you need these three very beautiful libraries. And that's why I want to send this to you. So if you don't have the library, you will need to install the package. So here I've written instructions. Here, this instruction says, if you don't have the read Excel file, install it. If you don't have the DPLYR file, install it. So this lines 339 to 341 is for new users who don't have these three libraries. So that when you run this code on your system, it's going to install the libraries for you. So that next time you wouldn't need to reinstall. That's what lines 338, 339 to 341 does. However, if you are not a new user, or if you already have the libraries in your as packages, and how do we get packages? We go to this pane here, first time we are coming there, And when we get there, we click on packages. And then we have packages that exist. There are some packages that are always there. But as you use it more, you have newer packages. For instance, I should have the DPLRY. So I have the DPLRY. I don't have that. So since I don't have that, I will go to line 339. I will run line 339, line 340, and line 341. When it is loading, you would have seen a red mark here. I didn't show you that on time. But it has loaded those libraries. And then in line 344, I'll bring in the library, the other library, and the other one. So this is a gift from me to you. So there's a data set called the Titanic data set. That is the data set that I want you to use as your exercise for the next 1 week. And that's why I want to share this file with you. And that's why I want you to listen, a bit more, because this now is trying to implement data science, even if you don't finish it. Remember that we've been able to create a data frame of our own. But now I want a situation whereby you'll be able to use real data set. And we can continue this conversation on our WhatsApp group. Okay? So there's a data set called the Titanic data set. I'm going to put it in the WhatsApp group later on. But on my own system, the data set is inside my downloads folder. I've called the data set Titanic1.csv. So it's inside this download folder. So by the time I'm able to understand this path, which is something that I will spend time to talk about next week, and I use read.csv, what I would have done is that Titanic data set that is inside my download, I've now brought it. I brought that Titanic data set to my R console, to my R environment, which means that if I go to line 353, I can say print Titanic. If I ask it to print Titanic, it's going to print that famous Titanic data set where there were people who boarded a ship that eventually, capsized. In that data set, there are several people there. Some died and some survived. So this particular data set has been used widely for data science. And it will be nice for me to introduce you to it. So I'm going to leave you today with an introduction to application of the things that we have done, an incomplete class, but a preparation for you where you can begin to search and see if on your own you can resolve some of the problems. So I want to explore the data set. First, I want to check the structure of the data set. I'll use the structured Titanic, this structure, this function. When I run that, it tells me, yes, it exists. But because I emphasize str, that's why it gave me that output. But if I run the entire line, it gives me the variables. Their sex, male and female, their ages, the number of siblings or spouse in the boat, the part of the ship that they were in, their ticket number, how much fare they paid, their cabin, when they came down from it or not, whether they embarked before the ship got wrecked. You can read this data library dictionary online. So if we check the summary, just that summary function, it gives us all these details, enough details. I want you to demonstrate it as like a take-home. If we do the head, it gives us the first 6 data points, first 6 individuals. If we do the tail, it gives us the last 6. So it means that there are about 890 people in that boat that got wrecked. If we want to check if there are missing numbers in line 362, it tells us, yes, there are 177 of them. If we want to check the column where they are missing, it tells you, yes, I know the column. It is age. So a lot of people don't give out their ages. Why? You might not be able to tell. So whereas I'm not going to complete this work, okay, so here we want to impute age. And we said one way to impute is to use the mean. So we'll use line 370 and impute the average for any missing values. We have cleverly given you this so that you can actually work on it. You are going to run this code on your own. We hope that it will work for you. So in our next class, we will complete this file. Okay, learn a lot from it. We'll go to this, our notes, complete the notes, and then we'll be ready for our next class. So I'm leaving you here today, hoping that you have learned some things. Good evening, everybody. You have any concerns? I want to stop sharing and I want to stop recording. Yes. Can we get feedback? Please, let's get feedback. We have